Hi guys, sorry I'm not in class today, but we have to do some work on chemical reactions. So I'm going to go through a very brief PowerPoint, some of which you may have seen, but we're going to recap the different types of chemical reactions so that you can do your activity for today. If I mess this up, I'm sorry. It's really hard to talk to you when you're not here. I'm sitting in my kitchen and talking to you, but you're not here. So it's like I'm talking to myself. Anyway, for chemical reactions, we've looked at 5 different types: synthesis, decomposition, single replacement, double replacement, and combustion reactions. We're going to break those down so that we can recognize them based on a chemical equation that's given to us. So the first type is a synthesis reaction. This is any time that you may have two substances and they're going to come together to react to make a single product. This is usually two separate elements that you see coming together to make a compound. So it might look like this. In this reaction, we have hydrogen gas plus oxygen gas coming together to make the compound water, or H2O. And you know that they're now stuck together in the products and bonded together in one molecule because there aren't any spaces between the elements. It's all written together in one big chunk, so I must have hydrogens, 2 of them, bonded to one oxygen atom. We also see that we have 2 molecules of that because we balance the equation, which you guys are masters at. The next type of reaction is a decomposition reaction. So this is really the opposite of what we just saw. When we decompose something, it's like breaking it down. So what's happening is you have one single reactant that's decomposing or breaking down into 2 or more products. So if we had compound AB, it would break down into elements A plus element B, 2 separate things. I have a really fancy picture here. I have this lovely couple together to represent the compound. They're bonded together like one thing, and then they break up, and now they're both separate. The relationship is decomposed. We've never experienced that. Here's the real reaction. It's the opposite of what we saw before. We have water breaking down into hydrogen and oxygen. Single replacement reactions are always going to involve one compound and then a separate element that's by itself. And that's going to react so that one thing is going to replace the spot, replace one of the elements in the compound. In order for that to happen, the element that's by itself in the beginning, like element C in this case, has to be more reactive than B, which it's kicking out of its relationship with A. I've got this fancy picture again. So we've got a couple, they're dancing, they're happy. And then Mr. Joe Cool, he is much more reactive. He's going to come in and steal this guy's girl. And now they're bonded together. And poor guy B is all by himself. An example of this is, say we have magnesium by itself. It's just elemental magnesium. And I put that in with some copper sulfate. The magnesium is much more reactive than the copper, so it's going to kick the copper out of its compound. Now the magnesium is bound in a compound to the sulfate, but the copper is by itself. The next type is a double replacement reaction, and this is where the cations, or those positively charged ions, are going to, and the anions, the negatively charged ions, are going to switch partners. So you have to have 2 compounds here in these types of reactions. So in this case, for the generic equation, we have compound AB plus compound CD, and they're going to switch partners. So now I have AC bonded together and BD bonded together. So in the picture, you'll see that you have, I don't even know their names anymore, Mario princesses. And they're switching. So these best friends and the other best friends now no longer hang out together because now they're bonded with somebody else and we have different partners. For a reaction, a real life thing that might happen, you might have silver, that's Ag, bonded with nitrate, NO3, plus some sodium chloride. And then the silver and the sodium end up switching places. And so now we end up with two different compounds because we rearrange the pieces of both. A combustion reaction is anytime we burn something. And you know that when you burn something, you've got to have oxygen present. And you're also going to make carbon dioxide, or CO2. The other thing you always make when you burn something is water. We always have water vapor that comes out of a combustion reaction. So we call the most important reactant here a hydrocarbon. That's hydro for hydrogen and carbon for carbon. And we can have that hydrogen and carbon in really any numbers for it to be considered a hydrocarbon or something we can burn. So in the reaction, you'll see we have C with just the little A for the subscript, and H has the B for the subscript. Those are because we can put any number there we want, and this is still a combustion reaction. You'll notice these because anytime you see that carbon hydrogen molecule plus oxygen, and the products are always, every single time, CO2 and water, you always have a combustion reaction. On your sheet from yesterday or 2 days ago for some of you, you should have your summary now completely filled out with all of the pieces. I know that in the equation box for combustion, it was probably difficult to fill that in based on this A, B, C thing that we had. So you might want to write it just like I have in this box with that CH molecule plus O2 producing CO2 plus H2O. Back, if you're here and say this number, the first one was the equation I was given, which we said was a synthesis reaction, I might describe that as two elements coming together to make one compound. That way I know that I'm talking about synthesis. When you're finished with that worksheet, which you will be today, it is due today at the end of class, then you're done. You can celebrate. Tomorrow you're going to have a checkpoint on balancing reactions, which we've been doing for a couple of weeks. These are going to be kind of your level 2 questions. If you're in period 2, you already did this, and that's awesome. You guys did a great job. And you're going to have some additional ones that are just slightly harder. And then we'll do some fun labs next week. Okay, thanks. Have a great day.